Welcome to This Explainer. Today, we're going to strip away all those sci-fi Hollywood tropes about conscious robots and discover what artificial intelligence actually is, how it evolved, and why it's already deeply integrated into your daily life. If you've ever felt like AI is just some mysterious sudden invention, well, you're absolutely in the right place. We're going to demystify the magic and look at the real science behind the hype. Can machines think? This profound question, famously asked by the brilliant British mathematician Alan Turing, is the ultimate hook that launched a massive 70-year scientific journey. You see, right after World War II, Turing proposed a really practical experiment to see if a machine could convincingly imitate human conversation. But to figure out if a machine could actually solve problems, recognize images, and learn from experience without being explicitly programmed, well, scientists had to embark on this epic quest spanning mathematics, computer science, and engineering. Okay, let's take a quick look at our roadmap. First, we'll cover the AI all around us. Then, we'll trace a 70-year journey. After that, we'll break down the 3 levels of AI, compare automation versus machine learning, and finally, separate myths, realities, and magic. Starting with Section 1, the AI all around us. Let's begin by acknowledging a pretty glaring disconnect. You interact with AI every single day, right? Yet a lot of people still mistake it for either a sudden new invention that just dropped out of nowhere, or worse, some sentient robot straight out of a blockbuster movie. But the reality brilliantly illustrates how AI isn't just futuristic magic at all. It's a highly practical tool already woven right into the fabric of our communications, our work, and our daily problem solving. Think about it. When your phone unlocks by scanning your face, or when Google Maps reroutes you around a nasty traffic jam, when Netflix knows exactly what movie you're craving, or when a bank suddenly blocks a fraudulent charge. That is artificial intelligence at work. It's not experiencing emotions, it's making highly intelligent decisions based on massive amounts of data. Moving into Section 2, a 70-year journey. Let's rewind the clock for a minute and see how this technology is actually the result of decades of continuous scientific discovery. And honestly, it started long before modern computers even existed. This journey literally started centuries ago. Thinkers like Leibniz in the 1600s imagined human reasoning as a form of calculation. Then, in the 1800s, Ada Lovelace had this incredible realization that machines could manipulate symbols, not just numbers. But the true foundation? That was born in 1956 at the Dartmouth Conference, where the term artificial intelligence was officially coined. For the next few decades, scientists tried building what they called expert systems. They'd manually type in thousands of logical rules, like if a patient has a fever, then consider infection. But as you can probably guess, writing rules for every single possible scenario quickly became completely impossible. The real world is just too incredibly messy. Intelligence, it turned out, was way more complex than they initially thought. Section 3, the 3 levels of AI. To properly evaluate AI without falling for all that science fiction hype, we absolutely have to categorize it into a rule of 3 framework. This helps us define exactly what its capabilities are right now and what they might be in the future. The first category is artificial narrow intelligence, or ANI. Look, almost everything marketed as AI today is artificial narrow intelligence, from ChatGPT writing code, to the DeepMind system that defeated the world champion in the board game Go, to facial recognition software. They excel in their specific domain, sometimes totally outperforming humans. But the catch? They cannot transfer that knowledge. You can't ask a chess-playing AI to diagnose a disease, and you definitely can't ask ChatGPT to physically repair your car. They're just highly, highly specialized. Let's move up to the second level, artificial general intelligence, or AGI. Now, let me be crystal clear here. This does not exist yet. AGI represents the flexible cross-domain reasoning that humans naturally possess. Think of a human scientist who uses math to solve biological problems and then goes home and applies physics to learn a musical instrument. AGI would be able to learn independently and transfer its knowledge across completely unrelated fields, just like we do. While plenty of researchers believe it's possible down the road, nobody has actually created it today. Finally, we have artificial superintelligence, or ASI, and this one remains strictly in the realm of theory and philosophy. This would be a system that vastly outperforms the brightest human experts in every single intellectual activity. We're talking about an intelligence capable of designing revolutionary medicines or discovering solutions to complex global challenges at a pace completely impossible for humans.
Brilliant thinkers like Stephen Hawking have discussed ASI pretty heavily, mostly focusing on the safety and mathematical alignment required to ensure any theoretical system of this magnitude operates exactly as intended. Okay, Section 4. Automation versus machine learning. Now that we've defined the boundaries and know that we are currently living firmly in the era of narrow AI, let's shift our focus to the massive paradigm shift of how it actually works. Frankly, this is the biggest aha moment of this entire explainer. If we contrast traditional programming with machine learning, the difference is just staggering. With automation, something like a calculator or a traffic light relies on explicit rules written by a human programmer. If the timer hits 60 seconds, the light turns red. The machine never learns anything. It just blindly follows instructions. But with machine learning, instead of giving the computer explicit rules, we give it data. If you want to build a spam filter, you don't waste time writing 1,000 rules about what words spammers use, because spammers are just going to change their words tomorrow. Instead, you feed the computer millions of emails already labeled as spam or not spam. The algorithm studies the examples, discovers the hidden patterns, and actually learns the rules itself. Think of this whole space like a Russian Matryoshka doll, or maybe a geographic map. Artificial intelligence is the entire country, the broad science. Inside that country, there's a large, bustling city called machine learning, where algorithms learn from data. And right inside that city, there's a highly specialized district called deep learning. Every deep learning system is technically machine learning, but it uses something called artificial neural networks, which are loosely inspired by the structure of the human brain. To see how deep learning specifically operates, just imagine feeding a neural network millions of photos to teach it to recognize a cat. The data moves through these computational layers. The very first layer might just detect basic edges and lines. Then, the second layer takes those edges and recognizes simple geometric shapes. The later layers start identifying really specific features. Think pointy ears, whiskers, and fur. Finally, the last layers combine all this mathematical information to confidently say, yes, this image contains a cat. It achieves this not by human comprehension, but by analyzing millions of pixels and calculating statistical probabilities across millions or even billions of parameters. It's pretty wild. Bringing us to Section 5, Myths, Realities, and Magic. As we wrap up this explainer, we really need to ground our understanding. So let's do some rapid-fire myth-busting to separate the media hype from the actual scientific reality. First off, it is absolutely essential to remember that modern AI does not experience emotion. It has no personal desires, no self-awareness. When ChatGPT talks to you, it's just predicting the next most appropriate word based on patterns it learned from massive text datasets. Second, because it relies heavily on probabilities, it frequently makes very confident mistakes, which researchers politely call hallucinations. This is exactly why human verification remains so critical. Third, while a human toddler can learn what a cat is after seeing just a couple of examples, AI requires thousands, maybe millions of examples to learn. And fourth, just like the steam engine or the internet before it, AI isn't going to simply replace every human job, it's going to transform them. It's going to automate the repetitive stuff while creating massive demand for people who can direct and evaluate these new systems. There's a great perspective from our source material that says, understanding this history helps us appreciate that artificial intelligence is not magic. It's the result of human curiosity, scientific discovery, mathematical innovation, and decades of continuous improvement. And that perfectly encapsulates our journey today. AI is undeniably powerful, but behind every single impressive chatbot, medical diagnostic tool, or image generator is merely a combination of complex statistics, powerful computer processing, and literal mountains of data. It is a massive triumph of science and engineering, not magic.
Which brings us to the ultimate cliffhanger. We know data is the fuel, right? And we know these systems find patterns, but I'm going to leave you with this final provocative thought. So how exactly does a machine mathematically learn from all that data without a human holding its hand? That sets the stage perfectly for our next explainer, where we're going to dive right under the hood into the actual mechanics, the training processes, and the hardcore mathematics of machine learning. You really won't want to miss it.